Alright, so last week we started to talk about feedback control. In particular, we discussed open loop control systems. This week we're going to start to talk about closed loop systems, where we introduce this notion of automatic adjustment of whatever the control input was based on some measurement. So we're introducing this concept of a feedback loop. And this kind of thing crops up in everyday life quite commonly. Think about things like thermostats, controlling temperatures of your house or room, and cruise control in your car, for example, are all examples of closed loop feedback systems. And another piece of terminology that crops up quite commonly when talking about closed loop systems is this idea of negative feedback. And negative feedback is based on the gain that is applied to the control input based on the feedback loop. So negative feedback generally promotes stability by trying to dampen out the perturbations in the output. So the system is adjusted so that the gain doesn't overcorrect the initial input. So it tends to have a dampening effect, and that's called negative feedback. So specifically what we're going to talk about here with closed loop systems is how they can aid the controllability of our airplane, not only in terms of stability control, but other types of closed loop systems as well, which help the aircraft to fly safely and also relieve the workload on the pilot too. So back in the days then, when people wore bowler hats and distinguished pilots weren't required to have a moustache, this fellow here, Lawrence Sperry, who incidentally was the guy who invented the artificial horizon as well, an early pioneer of aviation. He invented the very first autopilot system in 1912. Now, this was a consequence or result of the fact that very early aircraft were inherently very difficult to fly. They required intense concentration from the pilots just to keep the things in the air. And as flight times increased, so by the way, the invention of the first autopilot system was only 8 years after the very first flight by the Wright brothers, and as flight times increased from a few seconds at first to a few minutes to an hour or so, it was quite clear that the pilots needed some relief or some help with their concentration levels to help them fly the aircraft for a prolonged period of time. So the first autopilot system developed by Sperry was basically a series of gyroscopes which were linked to hydraulically operated control surfaces, the elevators and rudder specifically. By the way, it was already acknowledged at that time that it was wing dihedral that helped with roll stability, which is the reason why his system wasn't also fitted to the ailerons. So this system was quite successful and was used throughout the 20s and 30s on a number of aircraft, and also used successfully by the US Air Force in the Second World War. And just an example of how quickly autopilot systems developed, a US Air Force C-53, it's a Skytrooper, completed the very first transatlantic flight purely on the autopilot, and that included the takeoff and landing as well, and that was in 1953. So of course since then the technology has enhanced the capabilities of autopilot systems to the point these days where autopilot systems are mandatory on commercial aircraft, and we have some very complex and highly technological systems on fighter aircraft and that kind of thing. But still to this day, autopilot is commonly and affectionately referred to by pilots as George. And you can see a clip here from the movie Airplane. Now, if you haven't seen this movie, the first thing you need to do after we're done with class today is go and watch it, because it's an absolute classic. But you can see George there being inflated as the pilots on this particular flight were taken ill. So in addition to enhancing the aircraft's stability beyond that pure aerodynamics can provide, right, a modern autopilot system can also manipulate the controls, whether that's the control surfaces and whether that's vectoring the throttles as well, for example, to follow a pre-programmed flight path and or altitude, right? Modern aircraft may also be fitted with an instrument landing system, auto land features and that kind of thing, which all rely on what's called an inertial navigation system, an INS. And an INS basically uses a bunch of accelerometers, gyroscopes and that kind of thing to basically continuously measure various parameters about the flight condition and then provide information to the flight control computer, which makes a bunch of calculations for how to manipulate the controls in order to maintain this desired flight condition. So obviously these days the flight control computer is very sophisticated, can make many calculations per second, and basically provide a very high frequency feedback loop for our closed loop feedback loop.